I think you're going to love it today. It all ties in together between class and lab. And we've got to start though with this thought. I can't find a pen. I'll just tell you what I'm thinking. My first job out of my master's was down in Las Vegas. And I worked in Summerlin, his office down there with a bunch of other scientists out of the Yucca Mountain Project where they had been investigating the Yucca Mountain to store nuclear waste. And so they hired a lot of different kind of people. And one of them was Pat Letterly. Pat Letterly looked like Darwin. And I think he thought he was Darwin. He used to always joke. He'd always make fun of my religion and call out some of my prophets' names. But on his wall, he had Darwin on there. I'm like, I'm so glad you go home and pray to Darwin every night. That's your commitment to life. So we'd go back and forth as we're at it. But totally interesting guy. Next to him was Boone, Jim Boone, and I called him Booner. And Booner, totally nice guy. These are two PhD scientists who were both mammalogists. One's the small mammal, the other guy was looking at, they were both involved in tortoises and all kinds of stuff as research down there in the Mojave Desert. But Booner told me, he said, I think during my PhD days, the best advice I got was from this one guy. That was so ironic. But I thought a lot about this. He said, the best advice I got was on my finances. He said, the guy told me how to manage my money. And he said, it changed my perspective for life. I mean, there's a lot of things you have to hear. You want to get perspectives on how to be really good at studying plant community response to seed coding technology. You want to know that stuff, right? You got to have that down. But the finance part was this. So but this last 2 months ago, 3 months ago, I completed the self-reliance training that the church puts on. I encourage all of you to do some kind of self-reliance training. And this one, if you want to take advantage of it, maybe you're tied into that, some might not be tied into this, but there's this train that you can go in and you can learn about how to manage your money more effectively. So I did this. I should have done it when I was 23, 25. I should have. And I didn't. Did you find this thing on there? So pull up this little graph. This is the deal. He said, Booner said, if I had known about investing or managing money more carefully, and I'd done that earlier, that had been really advantageous. The weird thing is that if you go to Self-Reliance on the Tools app for the church, the whole thing is there. It's really cool. You can go through the whole training yourself, or you can go sign up for one of these classes. And they teach you the basics of how to be wise with your finances in your future. Anyway, they have a graph similar to this, but they blur it out. You can't read it. You have to get the little pamphlet and take the class. Otherwise, everything's blurred out. I'm like, why would you do that? But they did. The concept is the same as this. If you start to save your money at 25 to age 40, you will invest $150,000 if you put in how much? How much is it per year?
10,000 a year.
If you do 10,000 a year. If you start when you're 25, then that's how much you will have at age 40, right? So if you do that, start 25 at age 40, you'll have that? Or is that a retirement? Oh, at retirement. When you get to retirement. If you start when you are 35 and go to 65, you'll have to invest this much, and you're going to have that much in return. And it's all about the timing you start this. So if you're dropping in a couple $300 a month into an investment now, in your 20s, when you get to retirement, you are going to be loaded. If you start when you're 50, so if I right now were to start to do this, I would have to put in this much, and I would get this much out of that retirement. So the point is the earlier you can get your mind wrapped around this, and instead of just like, I don't tell my kids about buying cars and such or whatever. If you can take a little bit of that and slip that away and put an investment now. But my thought for the day, uplifting thought is, take this self-reliance course and do it. Even though you feel like, I'm not there yet. The sooner you understand this stuff and you can make sense of it and apply it, and especially if you do it through the organization that's been created that puts this in context of our purpose of life on Earth, it is very interesting.
What kind of investment is it like encouraging them to invest?
They say that your age, almost all you guys are doing Roths. like a Roth IRA is like the millennial thing. That's being done more than anything else. And there's high investment or high risk and low risk. At your age, you do high risk because if you blow it, you still got time to recover. But the high risk stuff pays off big time if it's a good one. I remember I was down, I still to this day, I'm like, I just didn't know. I went down to this building on Oregon State campus. I'm sitting with this dude, and he's like, well, let's do a search. I've been using Yahoo or whatever, and he pulled up this thing called Google. I'm like, well, that's pretty cool. He started showing how Google worked. I'm like, that's awesome. So I started using Google all the time. Had I known about stocks and thought about investing in Google stock, that'd have been awesome. Anyway, you decide about this, but that's my thought for the day, is at least give us some consideration and plan for your futures. And now on to the next part. We've got to talk about some drone stuff. All of you may have interest in flying drones. We've got a whole fleet upstairs. You're more than welcome to join in on this excitement and use them for your research. They can apply it in so many different ways. We've had people using drones in Neil Hansen's lab and in Brian Hopkins' lab doing remote sensing of crops and crop production using NDVI to see if you can pick up how much plants are stressed out. You and some others went over to the football field. Were you involved in that? You weren't. Looking at stress of grasses over the football stadium with Brian Hopkins. Brad Geary. I don't want to spoil all the fun. I don't know if you're going to talk about these. You're not going to talk about that? Brad Geary, he got a hold of us and said, how about we go over and look at corn? Can we measure corn? It was height. Really, he wanted to do a height assessment and gaps so we could see if corn is being depredated on by deer. It picks up that variability across the surface. The list goes on and on and on. There's so many different applications. To be able to fly a drone, you gotta get in on it. You gotta learn how to do it. So today and during the lab, you're going to have a chance to see some drones in action and be a part of it. The whole process of how to collect data, that's what he's going to talk about right now. But the one thing is, if you're going to be serious about doing this, you've got to be certified. You can't just go do this and wing it anymore. You can do it for hobby. He'll tell you the details of it. But my point is, if you want this for research, then you got to listen to what he's going to say and go take the test. Go take the test. Kate, go ahead.
Are you taking the test yet, Steve?
I don't want to talk about that. But I'm studying up. All I got to do is study. I have to review 2 more things. I'm going to take it. I will beat you too. I'm taking the test probably the next 3 weeks. I'm not going to tell you when I'm going to take it though. I'll tell you I'm going to take it and pass it. I'll let you know. If I don't pass, I'm not going to tell everybody until I become a video.
And also going along with lab 3, it is on Learning Suite. If you have time before lab, give it a once over. There are some instructions on how to use the Trimble GPS that we're going to be using in lab today, so if you can just take 5 minutes, go over that so you're not completely lost when we get there, that will be helpful.
Who here has never used Trimble, like a Trimble GeoXH, GeoXT GPS unit? Who has not used one before? More than half. 3/4 have not. So for you, this is really like the best kind of stuff that's in the field. Sorry, Ryan.
You're good.
I'm going to keep this brief. So there's a whole bunch of GPS units. Which ones have you used before? Name off some brands that you've touched and used before.
Garmin.
Garmin. You've all used Garmin's? Handhelds. You go out. How good's the accuracy on them?
Not super easy, but works.
It works. So you can do some working with them. You can work with them most of the time. And we did this for a lab once in here. I'm not sure we're going to do this semester. Maybe I'll squeeze it in at some point. But I took this class went out, and I said, "Here's your Garmin. Go out and collect some points the best you can, and come back." And it was the egg on campus, right? You know the egg. I had to go around. What that is if you go to the JFSB. You know, I'm talking about the JFSB that has that kind of design. Well, just pull it up real quick. I'm sorry, dude. This is so much easier to describe by pointing at it than using my waving of hands. If you don't mind. So we had Garmin's and we had Trimble, and we've got them both here. And the Garmin's, why would you buy a Garmin? Why would you want to take a Garmin out to do this GPS work? in natural resources. Why Garmin? Because we got 25 of them upstairs. I know the Brock and Randy's lab, they got, I don't know, a bucket full of them. I've got 4 or 5. I think everybody's got at least one because they're like $300, $300 to $500 you've got yourself a Garmin. Here's the egg, right? That's the egg. So I told everybody, I said, take your Garmin out and I want you to go GPS the egg and these little garden sites. And then I said, take this Trimble out and go do the same, which collects data with a rod. You got a little Stadia rod thing. You walk around, it's got a level on it. And you'll see that today because you're going to use it today. And we came back and compared. We downloaded the data and brought up into GIS, and the points, were you there for that one? The points were like up for Garmin. It was just, you could hardly even tell it was even a shape. For GIS, you could hardly even make it out what you were even looking at by taking those points and connecting them. And you can use the track log to actually combine them and make like a line feature. Then we used the Trimble, and the Trimble you would just land on the top of this and it looked like exactly like that. But you could not tell that you were off of it at all. Those Garmins are getting 3 to 5 meter-ish kind of resolution, accuracy, I mean. And the Trimble's 10 centimeters. It's like that. That's why you have that pole with the level on it, because a little bit of wobble and you're going to be that much off. 10 centimeters, you're hitting it like this. And so today, you're going to use this thing. My point is, if you're going to do any kind of GPS stuff for your projects, and you want to know right where you're at, come get that from me. I can check it out to you, you can take it. There's no reason you should be using a Garmin if you are worried about the accuracy of your data.
Is there a benefit to using like a Trimble or something that accurate for like navigation purposes? Like if you're out hiking or on like, you know what I mean? What is the benefit of being 10 centimeters versus what you said 5 meters?
Yeah.
What is the benefit in that?
So you'll see today why we're going to use it for is high resolution, high accuracy. There are times like we had photo points set up where I wanted to go back to the exact same place and I wanted to take a shot of the plant community off in this direction, and I wanted to be in the same location time after time. And we actually drove rebar in the ground so we could have that same place set up, just much above the ground. And then I wanted to go back and find it. So I started doing this before there was selective availability turned off. And that was before Bill Clinton was in, while he was in office. Before that, they had a scrambling on the system. They had scrambling on satellites.
Accurate, right?
They did not want you to have accuracy as a citizen.
Back then.
Yeah, so they would mess it up. So your signal was like all over the place on purpose, so that terrorists across the ocean weren't bombing us and killing us with our own GPS technology. And then around whatever year that was, 90s, Clinton said that's enough. These other countries have all got it figured out. We're not fooling anybody. All we're doing is just confusing our public. And so let's shut it off. So went from this to almost no variability. Anyway, so as a result of that, you can dial right in on things. You can walk right. So if you want to navigate to something, you can walk right into it. If you're going to map, if you're mapping boundaries that matter, or if you want to go, so you can do a line or a polygon feature, and it'll be really close to where it actually is, if that matters to you. But on the other hand, separating this plant community type from this one where it's a gradient, I'm not sure Trimble's really that big of a deal. Going from Wyoming ensis to mountain big sagebrush, Wyoming sagebrush to mountain big, it's usually at it's a gradient of elevation, water, soils. To get a Trimble, that's overkill.
What's the cost difference?
So Garmin's $300 to $500. The Trimble you'll use a day was $12,000 for the whole package. So there's a bit of a difference in cost, but the payoff is huge. If accuracy matters to you, it's huge. And I've got 2 of them sitting upstairs, and they're all ready. Take it away.
So we're going to talk a little bit about how drones, just a little bit about the history. Then, like Steve said, becoming certified. I'm going to walk you through a little bit of some of the bigger parts of the tests that you're going to have to take to get certified. Just as a springboard, if you wanted to study on your own, you can go get certified. And then, assuming there's some time at the end, I really have no idea how long this presentation is going to be. I will talk about my own research. Has anybody in here flown a drone before, either for research or recreation? And Nick, okay. So as you can imagine, drones have a military background. The first one that I was able to find was 1849 when Austria used balloons to bomb Venice. Not quite what we think of as a drone today, but I think it still counts. It's a pilotless vehicle. 1860, Nikola Tesla demonstrated being able to use radio waves to control a boat. The Kettering bug is that contraption up there in the top right. I'm trying to remember the description I saw. It was like a submarine with cardboard wings or something, is what somebody said it looked like. Basically, it's like one of those wind-up toys, like the cars, where like you pull it back and then you let it go. You wind it up a certain number of times, calculating the distance you want it to go, and then it would go and in theory crash into whatever you wanted it to. It was never used because the war ended before it was perfected. Then in World War II, they would send up pilots with planes, and then the pilots would jump out, and then they would control it with radio waves using CCTV to watch the controls and everything to pilot it. A few people died, like pilots died in the process. They never actually destroyed any of their targets, so it's pretty useless. But that was a few-year project. And then post 9/11 is when we started seeing the Predator and drones that we're more familiar with today. Drones are beneficial in military applications because they're good for longer flights where you have to worry about human fatigue, human error. Obviously there's not somebody in it, so there's less risk, basically no risk to the pilot. So from military, we started to see them become used more often in commercial applications, especially as smartphone and GPS technology have improved. So the first record I was able to find of anybody using one of these drones for a commercial purpose was following Hurricane Katrina. 10 years later, in 2016, the FAA introduced the Summary of Small Unmanned Aircraft Rule, also known as Part 107. They basically recognized that these drones, they're toys, everybody likes them, there's a lot of application for them commercially, they're going to become a big problem, so let's kind of get ahead of it and make more regulation, introducing them into the airspace so that we have fewer aircraft collisions and privacy concerns and all those things that come with drones. And then by about 2 years ago, there were 60,000 certificate holders authorized under Part 107.
Can I say another quick thing?
Yeah.
It'd be really great if there was 60,024. So if you can get your license, you'll be happy you have it, but it takes a little practice, and it's not something you just walk in and just go take the test. You've got to get geared up. He's going to tell you about this, but it's worth your time and effort. Before, we had some faculty, including myself, we were just going out and doing projects, but it's now to where if you try to publish a paper, it might become like iCook or the health stuff where you've got to get clearance to do this. They may actually check your paper and say, where's your Part 107 numbers and were you actually in charge of your aircraft during that research? And if not, they may not publish your stuff. So it's to the point where you've got to be pretty careful about what you're doing.
So the evolution of this to range light management, the first paper I was able to find that used drones in research was in 2003. George P. Jones, what a name, University of Florida. He used this guy. It's called the MLB Full Bat UAV system. It had a 1 hour flight time and a telemetry range of 3 kilometers, and it was automated. So that was his toy. I think we've come a long way since then, but before, like Steve was talking about, it was all balloons and kites / mini blimps used to take pictures of the ground. You can Google this, and there's all kinds of different cool things that people are doing with it, but you can use it to measure habitat. Like Steve mentioned, I'm not sure what this is, I just found this off of Google, but I imagine it's like NDVI of a crop field or something. You can see areas of stress, comparing the infrared bands to the red bands. They're being used in Africa to detect poachers. There's all kinds of things where people are using them to observe wildlife, do counts of sage grouse on leks and things like that. You can use them to chase horses and cows, which is lots of fun. This one lady, that's how I found, she would fly over whales and they would shoot their spouts up and collect that water because it had DNA and stuff in them, so she could track whales along their migration doing that. Collecting insects at high altitudes, all kinds of cool stuff. So, flying a drone typically falls either under commercial or hobby. Research is kind of more the commercial end. So to fly commercially, you have to have your Part 107 certification rating. Along with that comes age and flight restrictions, like you have to fly under 400 feet, you have to fly during the day, you have to be 16 to get your Part 107, and you have to register your aircraft over 55 pounds. You'll notice that for any hobby flights, it's basically the same rules. It used to be that the commercial flights would let you, was more flexible with you flying in airspace that you needed authorization in. They just made a change to allow hobbyists to fly. The rule used to be if you're flying recreationally, you had to be at least 5 miles from an airport. But now they're making some changes to that so that if you're a hobbyist, you can still fly in restricted airspace if you have permission. And also, you'll note at the bottom, there are rules, different cities, states, national and state parks, they all have their own stuff, so make sure that you check that before you go on. So Part 107, if you pass the test, you get this fancy card up here at the top. It's a 2-year permit. You can read all that. You have to be 16. There's restrictions on when you can fly, how fast you can fly, how big your aircraft can be. You have to maintain visual line of sight. You can have people help you with that, but you have to be able to see the drone at all times. You can't fly over people, you can't pose a risk to people on the ground, you can't do crazy things like drive from a moving vehicle, and then you have to operate in appropriate airspace. But as in all things, there are exceptions. You can apply for waivers for pretty much anything that you want to do. You just have to have a good reason for it and apply for that through the FAA, and they will give you a waiver if they deem it appropriate. So to get your Part 107, you have to pass the aeronautical knowledge test. This is $150 the first time you take it, and every 2 years you have to pay $150 again. The closest one, the closest location to take this test to here, where I went, at the Provo Airport, UVU has a flight school. It's a nice place. There's 60 questions, you have to get 80%, a variety of topics from the regulations to the airspace to emergency procedures. You have to be able to read, this up here is a sectional chart, so you have to be able to read one of those. There's all kinds of stuff online, free test prep, paid test prep. Once upon a time we had a login thing going around the department with videos and stuff. Those were really helpful. I don't know if that's still a thing, but if anybody's interested, we can look into that. So when you go and take your test, they'll give you this supplement guide. The nice thing is it has a legend, so you don't need to freak out too much about being able to read too many things. In there, they'll have those sectional charts. They'll have, they're called supplemental charts about airports, and they'll be like, what's the frequency of this airport? You have to be able to look that up, but there is a legend, so you don't have to worry too much about that. Now we're going to talk about airspace. Does anybody have their Part 107 other than Nick and Tom?
Anybody else? Nick and Tom? These guys right here. So there's 3 people in the room right now. Got it. That's it, right?
Well, where would you guys rank airspace as far as difficulty? Like all the different subjects you have to go over. Like was it pretty simple or?
I thought it was pretty simple. Yeah, I thought it was pretty straightforward. Yeah. I think it's probably like reading the letter codes. Yeah, that's probably hard. But also not hard. I mean, all is pretty straightforward, just stuff like learning. This is probably the most complex part of it, I would say, is airspace and reading sectional charts. Mm-hmm. But it's still like pretty straightforward.
I'd probably agree with that. So I'm going to give a brief overview of the different airspaces, and then I have a few examples that I'll test your knowledge. So the airspace is complicated. You can see there's all kinds of letters and shapes, and they're all overlapping, and it's crazy. So Class A is 18,000 feet and above, unless you're flying a jet. I don't think you can even get a drone to really fly at that altitude, so don't worry about Class A. So Class G is your friend. This is general, unrestricted airspace. It's from the surface up to 700 or 1,200 feet. AGL is above ground level until you hit Class E. So wherever Class E is, depending on where you are, that's how high Class G goes. And you don't need permission to fly in Class G. By the way, if you guys catch me making a mistake, feel free to. And this is the legend that you'll get in your sectional or in your supplemental thing when you take the test. So you'll have a little cheat sheet. Class E is everywhere controlled airspace. Basically anywhere on the sectional chart where it's not designated is Class E, starting at 700, 1,200 feet. And then it's designated by either a magenta shaded green thing or by this, it's right there, yeah, this, stand over here, this dotted magenta line. So, okay, so here's an example.
Here's a question right there.
Yeah.
Okay, so if you're on, say you're working for a company and they have a large property and you're flying a drone within company property, do you still need the license?
Yes.
You have to go to that sectional chart. You can pull those up from anywhere, and they're online.
Mm-hmm.
So you can look at these, and you have to look at those circles and the different colors of shaded magenta or blue, and you have to know where you are in relationship to those. And if you're in those rings or in those buffered areas, you've got to get clearance, or you're going to get in trouble.
Mm-hmm. They own the land, but they don't own the airspace, so that's why you need it if you're flying on private land.
Okay.
Yes.
This might be a random question, but I feel like there's a lot of like people who do weddings and like you can pay for video coverage or whatever, and they fly drones, and it's maybe like at the Salt Lake Temple or like these very heavily populated areas. Do they have to get special permission to do that? Obviously, because you're not supposed to fly over people. What is the deal with that?
I don't know actually if there's a waiver to be able to fly over people. The letter of the law is you can't fly over anybody who isn't part of the flight. So if you're flying over a group of people and they're all kind of part of it and they're all paying attention, then it's kind of gray, but it's mostly, they should be fine. It's more like if you're flying over a stadium or something where there's a bunch of people who wouldn't be paying attention and that kind of thing. So, so first they would have to worry about flying on private property owned by the church. If they got that approval, they're probably in the Salt Lake Airport airspace, so they would have to pay attention to that. I would have to look at the chart to see exactly where that would be, but
Yeah, it's not super.
if you're careful about it, you can do stuff like that. I bet a lot of those people aren't. A lot of people are probably not doing it correctly, but.
If I had my guess is this, before long, because of all the, how do you say about hobbyists, you don't have to go through this training if you're a hobbyist drone pilot. But those people are doing stuff in my mind is sketchy all the time. And all they always know, they don't know all these regulations and stuff. So I think it's a matter of time before everyone's required to do this if you're going to fly a drone. It's just going to have to be this way eventually. But you can fly over the Payson Temple, you can do it. But yeah, you have to check with the church that you're okay with that. And you can go 400 feet above the actual temple itself. So if you got a structure that's 200 feet up, you can get 600 feet above that. But there's all these regulations and stuff that you really need to know and be aware of. And if you don't, you get hammered. Right? I went to a conference in San Diego, and it was this Esri conference, and they had a remote sensing guy talking about stuff. And they went outside, and there was a dude out there flying a drone, but he was just demonstrating it at DJI, but he had to fly it. I mean, he was like these lines where he could fly and could not. Because you got thousands of people over here. He was not allowed to go put that over the top of that anywhere. So he had to stay above the road, over this area. You had to get all this clearance before you could just demonstrate how far this drone in that area. There's a lot of regulations that you need to be aware of.
And unfortunately, this is still such a new thing. A lot of even like law enforcement, they're not really super aware of the rules. Some of them are, I'm sure, but like I had a guy just from the Forest Service come up when I was doing my flights, middle of nowhere up by Strawberry. And he wasn't being a pain or anything, he just asked me what I was doing and everything, but like he didn't even know what permissions I needed. He was just like, well, there's this lady over here who's kind of over this, I don't know if you need to talk to her for permission. And I'm like, nope, I'm in Class G airspace and I have my thing, I'm good to go. So, yeah, you really have to know the rules because A, so you don't get in trouble, and B, so then if somebody comes up to you and gets mad at you for following the rules because they don't know what the rules are, then you can kind of defend yourself.
And today we're going in Class G airspace.
Yes.
We're on the border, right? We are right on the fringe of.
Yeah, I've got a picture of that later.
Okay, we'll go.
So this is I think this is a random airport in Missouri or something that I just kind of zoomed in on. So the darker line is Class C, which we'll talk about later, but you'll see this magenta line, that's all Class E. And so you can see that you really have to pay attention especially when you're around airports, and make sure that you're accounting for all the different airspaces that are there. So this is which one is that? Can't read that. Nephi, that's Nephi Airport. So that's Class E. This one is St. George. So you can see that this has both types of Class E airspace. So here is Class E from 700 feet up, and then this magenta line is Class E from the surface to 700 feet. So close to the airport, you're in Class E from the surface, and then further away you're in Class E above 700 feet.
And outside of that is Class C, that's 1,200 feet.
Yes, so like right here, it's Class E at 1,200, and it's Class G up until 1,200. So the next one is Class D. These are your dinky airports. While the control tower is operation, it's Class D. When the control tower is not in operation, it becomes Class E. And then this right here tells you the ceiling of the Class E airspace in hundreds of feet AGL. So like this says 40 right there, so this would be 40 hundreds of feet, 4,000 feet above ground level. So an example of this is Provo. So you have the Spanish Fork Airport, that's all Class E, and then Provo is Class D. And it has this little shape like that. So from the surface to 7,000 feet, it's Class D airspace. So this is the chart supplement. That's kind of hard to read, but right here it has the tower information, so it has the tower frequency, and then it has 1400 to 0400 Zulu time. So that's, I think, 8 a.m. to 10 p.m. the control tower's in operation, which is pretty much daylight hours, but if you had a waiver to fly at night, then you could actually fly in the Class E airspace with authorization outside of that time frame. Sometimes the control tower will close at like 4 or 5 at night, and so you're free to fly after that, as long as the control tower is closed.
So based on that map, pretty much anyone flying in Provo, unless they have permission,
Yep.
should it be during
yeah.
the daylight?
Yep. And fun fact about BYU, if you want to fly on campus, or technically if you want to fly at all, you have to contact risk management. They have a little application that you fill out to plan a drone flight. BYU has a deal with the Provo Airport to allow any flights up to 200 feet. So if you ever have a reason to fly on campus, then BYU can give you authorization to fly up to 200 feet.
But to go with that, what he's saying also is that if you just want to go fly a drone on BYU, you are highly discouraged from doing that. Do not do that. Maybe you can get in trouble. You've got to get permission. So you have to think about these charts and what the airport or the restrictions are, but then just BYU campus alone. They will not allow you to go fly with them.
So Class C airspace is your larger cities. They have a control tower and radar, and they're marked by this darker magenta line. So this is the Albuquerque Airport. So you'll see this is all Class C, and then you also have your Class E. Then you have a smaller airport over here that's Class D. And this is where all the numbers change to mean sea level. So you'll see surface to 94, right, that says 94. So from the surface to 9,400 feet mean sea level, not above ground level. So that's actual elevation, not 9,400 feet above your head. Class B is your big airports. So Salt Lake is the Class B airspace. It's marked by the solid blue line. and the ceiling is in hundreds of feet, mean sea level, just like Class C. So this is Seattle. You can see it's kind of a mess. Yeah. So on the test, it'll be like there's a tower right here that you want to inspect. What's the airspace and can you fly that kind of thing? And so there are all these little shapes, like this shape right here. It's from 5,000 feet to 7,000 feet, but then like this shape right here is 3,000 feet to 10,000 feet, and so you really have to kind of look with your Class B airspace to figure it out. It's complicated. That's probably some of the more complicated questions that you'll get on the test is dealing with Class B airspace and just figuring out how everything works together. Okay, so now I have a couple practice questions for you. So that red dot on the map is my study area. If I wanted to fly under 400 feet, do I need authorization? And what airspace is it? So it doesn't say that there's any airspace. The only airspace you see is for the Heber Airport up here, but I'm well outside of that. Yeah. So it's Class G up to 1,200 feet, and then above that, it's Class C. Which is fine, because I can't fly over 400 feet anyway without a waiver. Okay, so what about if I wanted to fly within the airspace of the Ephraim Airport? What class of airspace is that, and can I fly under 400 feet?
Is it D?
D is the blue, the solid blue line. Yep, this is Class E. Does it start at 700 or 1,200? 700. And this is all in the legend, so you don't have to worry that much about that.
It's 700 and up, right? It's not from ground level, it's 700 and up.
Yep, 700 up until you hit A.
So if you have a drone, you're flying at 400 feet, and then what? Any thoughts? It's Class G.
So it's Class G up until 700 feet, and then it's Class E 700 feet and above. So if you wanted to fly right here at the reservoir, you could. Best practice, you might want to let the airport know, just so that they're aware that you're planning a flight, but technically you don't need to.
That is a great question, that was awesome.
Okay, so this is the Salt Lake Airport. That red X is on Antelope Island. That might be kind of small to be able to read. So Antelope Island has a rule that you can't fly from March to November, and then December and February you need a permit that you have to pay for. But pretend that Antelope Island doesn't care if you fly a drone. Just looking at the airspace, could I fly there on that X under 400 feet? I'll help read some stuff for you. So this box right here that it's contained in, up there, or right here, it starts at 7,800 feet and goes up to 12,000 feet, mean sea level. You also have your Class E airspace right here that it's contained in, and the highest point on the island looks like it's right there, just under 6,600 feet. Okay, so we'll do this by layers.
Any guesses?
The Class B airspace, is the Class B airspace going to be a problem? If it starts at 7,800 feet and goes until 1,200?
No.
No. So Class B airspace, forget. What about the Class E airspace? 700 feet.
No, because we're flying at 4, right?
Yep. So this is kind of what it looks like if you were to stack the airspace on top of each other. So you have your Class E at 700 feet, and your Class B from 78 to 12,000 feet. And so flying at 400 feet, we're good in Class G. However, what if we went up here to the north end of the island, and we were in this dotted magenta airspace, which is Class E from the surface. So there is no Class G underneath that airspace that we can fly in. So if we were up here, we would need authorization from whatever airport up here that it's a part of, fly in that area. So don't freak out too much about all this. This won't really be on like a test in this class or anything. This is just to let you know what's coming if you decide to take the test. But and then if you want to do drone research, just know that this is in your future, making sure that you're not flying in controlled airspace, which most of you probably won't be, because as a general rule, we usually study remote areas, so you won't necessarily be flying in Class B airspace most of the time. But so here are some resources that you can look into. SkyVector has all of these sectional charts all stitched together. It's where I got all these screenshots from. AirMap is kind of like SkyVector, except it's a little cleaner. It's more like a GIS web map. So for example, this is the Provo Class B airspace from a sectional chart. So like if we wanted to fly at Rock Canyon, it's right on the border. So if you wanted to know exactly, you might go to AirMap and you'd see that the Class B airspace ends right there, Rock Canyon's right there, you're outside the airspace. AirNav and and that FAA website, they have some stuff that's useful for the test, like your sectional or your chart supplements and stuff like that. Probably won't need it for most of your research, but there can be some useful information in there if you need it. So notice to airmen are just they're official releases of hazards that you need to be aware of, things like snow and birds. So that's a good thing to check before you go out and fly too. One type of notice to airmen is a temporary flight restriction. This is a very good thing to check, because if there is a temporary flight restriction, you're not allowed to fly. So for example, last year my study area was on fire, and so they made a temporary flight restriction. I couldn't fly while that temporary flight restriction was in place. They also do it if like there's VIP travel or other emergencies. Don't fly there, you'll get in trouble. They'll also ask you about weather. I'm not going to do a whole lot with weather. It was not my favorite part, but the one thing I will talk about though is density altitude. The height that your drone feels like it's flying. I don't really like that description, but I don't really know a better way to say it. Basically, if you have thinner air, then your drone doesn't fly as well as if you had thicker air. And so you get thinner air when you have higher temperatures, higher humidity, higher elevation, and lower atmospheric pressure. That all kind of makes sense. They're also going to test you about how thunderstorms form and what wind shear is and stuff like that. Yeah.
It's super important to keep into account as well, because like I'm flying up to like 10,000 feet in the first year. We didn't like know about this really, and so our drone just kept falling out of the air, just kept stalling, and would just like drop like 100 feet and then crash. And no one knew what was going on, and everyone just thought that Tom and I sucked at flying drones. It wasn't true. Air was too thin, so and it had too heavy a payload on it. So just keep that into account if you fly high.
Yep. Weather plays a big role in the performance of your drone. So if you're not sure like how rain affects your drone or something, you can just Google how does rain affect the drone. If you have a specific question like that, just make sure that your drone will perform well in the situation that you're flying it in. METAR reports are official weather reports, usually put out by an airport at that, like the airport acts as a weather station. And they'll send out a code like this, and as part of your test, they'll most likely ask you a question or two about specific aspects of weather based on that code. I'll just go through that real quick. That's not. So you have your station identifier at the beginning. This is the time, so the 22nd day of the month, and then 01:36 Zulu time. The next one is wind, so it's coming from 310 degrees at 6 knots. Your visibility is 10 statute miles. You have few clouds at 2,000 feet, broken clouds at 2,400 feet, and overcast clouds at 4,900 feet. Then you have your temperature and your dew point, and then your altimeter, pressure, and then remarks that you need a key for. This is just something that's going to take some practice, memorizing the order of everything, and just getting a bunch of samples and reading it. Again, that only really matters to you if you're going to take the test, so don't freak out. So some best practices about planning a flight. Always inspect your equipment. Make sure your propellers aren't dinged up and your batteries aren't exploded and everything looks good. It's not a bad idea to make a checklist to make sure you get everything. Check the weather. One thing that I like to do is I'll check the METAR report, and then I'll just take a screenshot of it so I have a record, just so that if something happens, then I can be like, well, when I flew, there were clouds or I don't know, whatever. Just so you have a record of weather conditions. Keep a log, especially if you have multiple batteries, so that you can kind of use each battery the same number of times, and so you don't have one battery that you use all the time and one battery that you never use. You can kind of cycle through things. Make sure you check your airspace. Download any base maps that you need before you go out and you're in a remote area and you don't have internet access. I've done that before. And then make sure everybody who's involved knows what's going on. Train them if you need to. I can talk about mine real quick. So I was wondering if we could use a drone to measure the height of sagebrush in my study area. And then I was wondering what the best way, assuming it works, what are the best parameters to measure it, taking into account covering the most area, being the most accurate, and being the fastest that it could be. So we used a method called photogrammetry that you take all your pictures with your drone and then you run it through a software called Pix4D. It stitches everything together and it looks at the overlap between the pictures, and magically it gives you a little point cloud, kind of like what you get from LiDAR. And so here's your actual picture, and then here's a raster layer of plant height, so you can see visually things kind of match up. You can be like, oh, there's a bush that's higher than the bare ground next to it. So in theory, this would work. And so I flew at 4 different heights. Sorry, I kind of go back and forth between feet and meters because some of this is for presentation, some of it's for publication. So different heights, and then single pass like this, and then double pass like this. So you get 2 pictures of the same bush. And then continuous and safe mode. So if the drone just flies and takes pictures, or if it stops and takes a picture, and then keeps going and takes another picture. So you can see kind of the differences in flight time as you go up in altitude, and as you go from double pass to single pass and safe mode to continuous mode. Obviously, single pass continuous is the fastest if you're at highest altitudes, but your resolution is also a lot coarser, and so where's kind of the happy medium between I'm covering a big area, but I'm also getting high enough resolution that I can still kind of make a good model. So I did a bunch of flights and a bunch of processing, and I got pretty good correlation between what I measured on the ground and what I measured from the drone. That's one benefit of using the Trimble. Just another pitch for that. It's important to determine the actual bush that we're measuring so that we can compare it on the ground to what we get in the imagery. So we really need that 10 centimeter precision. So one thing that we did is we kind of corrected the heights using linear regression. So we just compared what we measured on the ground, what we got from the imagery, got that equation, and then used that to kind of correct everything. So uncorrected, we range from 15-ish centimeters up to about 30 centimeters difference average. If we corrected it, then we're right around 10 for everything. And so if you have the equipment to be able to run this correction, then you might as well fly at 120 feet because your average difference is going to be about the same as if you take all the time to fly at 100 feet. And this is kind of the same thing. So about 90% of our points were within 20 centimeters across the board. And so if you're measuring sagebrush, like how precise do you have to be in your height. We also had a bunch of points within 5 centimeters after it was corrected, and so it's kind of what's the trade-off between time and accuracy there. I think that's all I got. Yeah, here's a nice sunset drone picture for you. Get excited for this afternoon. But
Any other questions?
yeah.
Is the Before You Fly app, is that like reliable? Like, do you use that before you go out, or?
I don't use that. I probably should. I actually don't even really remember what's on there. So
Okay, fair enough.
I will look into that and let you know what lab does that.
Just really quick, just say, any three of you, how long did it take you to prep for this test before you went and took it back? They probably only 7.
I probably spent like a week and a half or so.
So there's a whole training session that's online. It's probably worth your time to go through. So the guy explains what you need to know. They give you practice tests to go through and get ready for it. So if you're serious about doing this, we can get you set to where you can go through that. It'll take about 2 weeks, heavy hours a day in 2 weeks. Couple 3.
Yeah.
So that's it. Just, if you want to do it, let's do it. And you can try to get your cost to pay for it if you're using drones for your study. It's $150 for it. So you're getting data you can have some confidence with you did it correctly. Thanks, Ryan. Thank you. Appreciate that. That's great. Okay, so you guys at 2 o'clock. Remember the loading docks? We've got 2 vans down there, so we'll be there at 2 o'clock. We'll go through the canyon.